What is a tree, what is a graph, and how are they related? My name is Alan Doran. You don't need to have seen any videos before watching this one. It's quite simple to understand. What is a tree? Well, you just need to look out the window to know what we think of as a tree in the context of nature, but in computer science we have a similar concept. A tree is a data structure. It's usually represented as a collection of nodes, here drawn as circles, and these are linked by arcs, which are represented by lines. Each of the nodes in the tree has its own name depending on its position. Here, highlighted in green, we can see what are known as the leaf nodes, and they correspond in their position to leaves on a tree. The bottom of the tree is called the root node. That's the base of the trunk, if you like. And from here, the tree branches out towards the leaves. The nodes in the middle are neither leaves nor the root of the tree, and they're called internal nodes. Every tree is made up of a subtree, and here you can see outlined in the grey box a subtree from the original tree. Each subtree has a root. In this case it's highlighted, or it's indicated by the arrow, and of course it will have possibly, well, at least some internodes and some leaves. If you were to walk around outside and break a branch off a tree, a real tree that is, and look at it, it too would acquire a root node. That would be where you broke the branch off, and it would have leaf nodes and internal nodes too. Now, often in computer science we draw our trees upside down. In this case, the root node becomes the top of the tree, and the tree branches through its internal nodes to the leaves, which are drawn at the bottom. Now, in a tree we have an implicit order, and this order runs from the root of the tree to the leaves. Any subtree within the main tree also has this order. So if, for instance, we look at the subtree designated by the grey box at the top of this tree, including the main root, we can see that the root forms the parent of what are called its left and right children. We can also say that the root node is the ancestor of its left and right children. Similarly, with the grey box, the bottom left of the original tree here, we can take the root of the subtree to be the parent or ancestor of two children, the left child and the right child, its descendants. Now, these aren't the only subtrees we can have within this tree. Here's another one. We can exclude the two leaf nodes on the bottom left and just say here that the top right node in the red box is the parent of a single child to its left. Now, the children of a node are ordered. That is, we have a numerical or linguistic way of running from one to the next onwards, enumerating all of the children. Now, in this case, the parent in the red box has only a single child, and it's its left child. Here's another subtree. The way this is drawn, the parent in this subtree, shown in the red box on the right, has only a single child, but it's drawn as the right child, so this node has no left child. Sometimes we might order things from first, second, third numerically. In this case, we could say that both of the parents in the red box on the left and the red box on the right just have a single first descendant. Now, in a tree, these arcs, or the connections between the levels in the tree, form a hierarchy from ancestors to descendants. So we can think of these connections as being directed. That is, they have a direction that travels from the root node of the tree down to the leaves. Now, if I wanted to, I could of course add a new arc to the tree. Here you can see a new arc indicated in red, travelling from what was an internal node to what was a leaf node. Now this makes a graph. It breaks the rule that the tree is directed from ancestor to descendant, and in actual fact, the leaf node over on the right now has two parents, which is illegal in a tree. In a tree, each node can only have a single parent. It can have more than one if it likes, children, possibly no children. Now a graph can be directed, as we just saw, or it can also be undirected, like the one in this picture. And if we look at this one, we can see that there's a clear loop running from the root node down its left branch and then cutting across the new arc to the leaf node on the right and back up to the root. If we have a loop like this, it's called a cyclic graph. A graph can also be acyclic, that is, it has no cycles. And that's really all there is to the terminology of trees and graphs for now. So in summary, a tree is a set of nodes connected by arcs. The arcs are directed from parent nodes to each of their 0 or more children, and a tree cannot have cycles. A graph is also a set of nodes connected by arcs, and it can be directed or not. A graph may have cycles, or it may be acyclic. Thanks for watching.